Okay, here's a very quick, rough video as promised on how to basically get the stepper motor working for the Tippy Marble Clock from the Engineezy channel. This is not the full 100% accurate using a real-time clock option. It's also not what is referenced in the video that the Engineezy channel links to. That uses a custom board and a single power supply to do everything. This, to my mind, is much easier and to all intents and purposes almost as accurate. What you need is an Arduino. You need a A4988 stepper motor driver chip and corresponding board. I bought the Tech 42 versions from Amazon. They fit together, and you need a cable from that to your NEMA 17 stepper motor, and you need a few little cables to connect them up. The Arduino has two power supplies, a 5-volt USB, which when you're programming it, obviously connects to your computer, and then there's also a 12-volt that you can use instead if you want. You don't obviously have to connect it to the computer every single time, only when you're programming. When you repower it up the next time, it will just start running the software. You also need a few cables to connect the two, and these came with the Arduino kit that I bought. That's about it. The wiring is very simple. You can see that there's a ground line and a 5-volt line on this side, and there are ports on the other side, and I've connected into ports 4, 5 and 6. The wiring is moderately loose, and you do need to press down and make sure it's all connected. Obviously if you're using it full time, you'd maybe want to solder or do something more. On the stepper motor driver, it's fairly easy. There is a 12-volt in, which I just connect to a normal power supply here. There is the connection off to the stepper motor. The chip plugs in the right way round into the sockets, and then at the other side there's 3 layers of pins. One is the ground, one is the 5 volts, and one is 3 pins that I'm just trying to focus for you. Do direction, steps and enable. Those connect to the relevant pins on the Arduino, and you need to remember which is which when you're programming it. The only other thing to point out is the dip switches, which I've set to the most number of microsteps to try and make it as smooth as possible. For me, on this board, that's all 3 on. Another thing to show is a screw that allows you to change the ampage being delivered to the NEMA stepper motor. You can watch videos on how to use a meter and measure the voltage the current accurately. However, I found that just having it about 2/3 of the way up works, and if it's underpowered, turn it up a bit. If it's working, just turn it down a bit until it struggles to work. That's basically the wiring. All you need to do then is install the Arduino software development kit, which you can get off their website, and basically run the code that I'm going to give you. You literally select the correct Arduino when it's connected. You'll probably only have one, and press upload once you've opened the file. This squirts it onto the chip and starts running automatically, and it's that simple. The code I've written is very basic. It doesn't use any libraries to make life easy, and as previous, the downside of this is I haven't connected a real-time clock module. What the code does is every minute it resets itself, and I've timed it and it's fairly accurate. I'm not convinced I'd ever leave this running for more than a few hours, certainly not unsupervised, so I don't think I'm ever going to actually really need the high level of accuracy.